So when SAP has started, hi, welcome to the 9th session on SAP CRM technical training. In this session, we are going to cover the complete details about the component architecture within the CRM Web Client UI framework. So when SAP has started with Web Client UI, they have come up with this componentization concept wherein the functionality within the application has been divided into multiple components. When SAP has started with IC Web Client, they had only one component for the whole functionality with FireAuto, and the complete functionality was driven through different views within the same component. So that was the concept which they used to use. So the T code to open the workbench at that time was BSP_WD_workbench, and the application name was CRM_IC. So this was the single application which was used for the complete functionality within SAP CRM. Whereas with 7.0, when the Web Client UI framework has come into picture, they have come up with the componentization concept wherein all the components are reusable and every component has its own functionality which is clearly defined. So the whole functionality of SAP CRM has been divided into different components, and that is what we are looking at right now. So the components can be, so as I mentioned, the whole functionality has been divided into multiple components, and out of these components there are three types of components which are majorly visible in all the types of functionality. One is for search. So this component is normally used to search for a particular object. Then the header component, which is used to show the details of the particular object which we searched for. Then we have a main component which will embed both search and header component into it and show us the details. So the main component is the component which is generally tagged with the navigation bar, and the navigation happens from the search component to the header component from the main component. So main component is the face of the components which we developed for searching and showing the details, and the main component will not have any views at all in general. So the main component is just to embed both search component and header component. So this is how it works. And further to this, when we talk about the types of components, we also have three types of components which are generally available in the SAP CRM system. The first one being the technical components. Technical components are the components which are used to develop a functionality which is useful for the developer or the functional consultants. So for example, there is a component which is used to create web services. So that's a kind of technical component. There is a component which can be used by functional consultants to do the configuration from WebUI itself. So that is a kind of technical component. Likewise, any component which is used to realize the technical functionality is known as a technical component. Then coming to generic services components. So there are few components which are extensively used across the other components. Such components are known as generic services components. One of the example of such components is GS nodes. So this is a component which is used across multiple components. Wherever we need to display any text types, we use this component. So this component has been named as GS text because it is a generic service. So likewise, all the generic service components are named starting with GS. So that's the indication that it is a generic services component. Apart from the technical component and generic services components, there are the other components which are created for realizing the business functionality, like your BP head or BP_head_search. All these components which are created to realize the actual business functionality are known as business application components. So these are the major types of components which we have, and most of the components in SAP CRM system would be business application components, and then the generic services components, and the least would be the technical components. So now we will look at the in detail architecture of a particular UI component. We'll go forward. So as we had discussed, any component which is built within the WebUI framework is technically a BSP application, and second thing is it has been implemented using the MVC pattern. So to get a better overview of MVC architecture, we are reiterating on the MVC model again. So in MVC, basically the model is responsible for holding the application state, and view is responsible for displaying whatever data is present in the model, and controller will do the event handling and navigation. So to be precise, model is handling the internal data processing, and view gives out the graphical output to the user by looking at the data which is present in the model along with the buttons, menus and the input fields which are required. And whatever interaction the user does with the view will be taken care by the controller. So the reaction to the interaction which the user does with the view will be taken care by the controller. So moving forward, so in a component, the major parts we have are views, view sets and windows. So view is the smallest unit in which we display the data to the end user, and this is where the user can interact with. And when we need to display more than one view, we combine them into a view set. So view set is a part where we can divide the view set into multiple areas and embed views into those areas. So basically view set is a combination of multiple views which are under single view set. Then we have a window which is basically going to embed views or view sets in it. So in case it is having view in it, we will be able to display only one view. If it is having view set embedded into it, then we will be able to display multiple views. In any case, views cannot exist outside the UI component. So the views can only exist within the UI component which is under the T code BSP WD CMP WB. So you can only create views within a particular component. And talking about the view, every view contains a view controller, an implementation class, then a context and context nodes. So the implementation class is the main class of the controller which is responsible for event handling, navigation, etc. And context is going to link your context nodes to the implementation class. So that's the use of context. And your context nodes are the actual nodes which hold the data. When we talk about the technical differences between view, view set and window, every view set and window are also technically views, but the way they have been implemented is a bit different. So your view and view set will have a .htm, whereas your window will not have a .htm page, which means you cannot display anything by just using a window. You have to have a view or a view set within the window to display something. So moving forward, so this is the slide where we are looking at a view controller. So as you can see, all the context related methods, the toolbar related methods, the request processing methods, everything come under view controller. Only the context and context nodes come under model, and the .htm page comes under the view, and rest all which are present over the screen are coming under the controller. So as you can see, even the controller initialization methods, then the request processing methods, the context related methods, everything comes under the controller part. And also there is a general misconception that the MVC concept which we are discussing has been implemented at a component level, but the actual reality is the MVC concept has been implemented within a particular view. Within a view, we have a .htm page which shows us the data and which acts as a view, and we have a context and context nodes which act as a model, and we have the remaining part which acts as the controller. So this is where it has been actually implemented and not at the component level. So in general, there is a misconception that the MVC pattern is implemented at the component level, but that's not true. It has been implemented at a particular view level. So moving forward, So as we had mentioned, a particular view cannot be shown without a window. Though you can create the views within the component, without assigning the view to a window, you will not be able to show it on the screen. So assignment of view to window is done in the runtime repository editor, where we can define which all views are a part of a particular window. And in case if you need to show multiple views within a window, as I had mentioned already, we need to create a view set, then assign the views to view set within the runtime repository editor, then assign the view set to windows within the runtime repository editor. So without this assignment of view set to window, you will not be able to see the views which you have assigned to the view set. So either your view or view set has to be assigned to the window before you can see it on the screen. And every view has its own view controller, and it is the first controller which will be started when the view is loaded. And the view controller will stay until the view is loaded within the runtime. So if the view is navigated away, then the controller dies. Same is the case with the context of the view as well. So the context of the view will hold the data within the context nodes. So this data will stay alive till the view is displayed. Once the view is not displayed, the data dies. So basically, these context nodes have a structure which holds the data at the runtime, either from the user input or from the bool entities. So in case it is a scenario where the user is entering the data and that has to be saved to the DB, then they will hold the data which is given by the user and then push it to the database. Likewise, there might be a scenario where we are searching for a data and retrieving it. There, the data from the bool is set into the context node and then displayed to the end user. So basically, context nodes acts as a bridge between your data which is shown on the screen and the data which is saved to the database. So that's the reason it has the same structure as the bool. So that acts as a bridge between your bool and your presentation layer. And the navigation is taken care by view controller whenever the user does an action on a particular button or any other screen element which is targeted at navigating. So on a whole, to summarize, view is the part where the user can interact with, and it takes care of handling the user actions, and context stores the data at runtime using the context nodes, and it acts as a bridge between the data within the bool and your presentation layer. Also, when your controller dies, the data within that also dies. So moving forward, so here we will discuss about the event handlers. So event handlers are basically used to handle the request from the user. So any kind of interaction the user does with the screen which is displayed in front of him, so such requests are handled with the events. So for example, a user might create a new entry and click save, or he might click cancel, or he might click on search button. So whatever request the user does, that has to be processed using events. And we have a method called do handle event, do underscore handle underscore event, within every view controller, which takes care of the event handling of that particular view. So this method is responsible for dispatching the control to a particular method which is responsible for taking care of that particular event. So for example, for an event called save, we will have a method called eh underscore on save. So that is the general naming convention. So when you try to create a new event by right clicking on the event handler node, it will create an event handler method with the name of the event which you have given by adding a prefix which is eh underscore on. So for example, I give a event name search, then the method name would be eh underscore on search. And what this essentially does is it will create the method, and it will also create a call for this method within the do handle event. So inside the do handle event, you will be seeing a method call which does when the event raised is equal to search. So when the event raised is equal to search, it will call the method eh on search. So that's the general way the event handling works. So we will see this in the system as well. And basically the event handlers are the methods which are there to handle that particular event. For example, if you say that I want to search for a particular business object. So when you click on search, it is supposed to search for that business object and set the results to the result view. So this is the expectation from the end user. So this can be handled within the EH on search, and the end user would be able to see the result based on the code we write in the EH on search. So to summarize, event handlers are the methods which are used to handle the events which are performed by the user on the view. So event handlers will not be seen in any other parts. These are only present within the views, because Windows and other controllers cannot talk to the user. Only view controller can talk to the user, because view is the part which is actually displaying the data. Said that, we will move forward. So here we are talking about plugs. So plugs are of two types. One is inbound plug and the other is outbound plug. Inbound plugs are responsible for inward navigation and outbound plugs are responsible for outward navigation. So when we say inward navigation, that is to navigate from anywhere to this particular view. And likewise, when we say outward navigation, that is to navigate from this particular view to any other view. So these are the two types of plugs we have, and you can right click on any type of the plug and give create. Like we had the event handler method generated with the prefix EH on. Likewise, here the methods are generated with IP underscore for inbound plug and OP underscore for outbound plug. So this is the general naming convention which is followed by SAP. IP is for inbound plug and OP is for outbound plug. And these are the methods where we can handle the navigation which is related to inbound or outbound. So moving forward, so to talk about the view layout is basically a .html page which is created for every view. So when you create the view, the .html page is automatically created for that particular view. And here you will be writing the code either in THTMLB tags or CHTMLB tags. And when we have a CHTMLB tag, automatically the configuration tab would be enabled. And most of the screen elements which we see on the screen are basically created out of either CHTMLB or THTMLB. And even if you use CHTMLB, it indeed uses THTMLB inside it within the CHTMLB tag. So we need not worry about what is used inside, but basically we create the view layout using either CHTMLB or THTMLB. And whenever we use CHTMLB, that will become a configurable view. And the way the data is transferred from the context nodes to the view is every view will have page attributes which are having the same name and type as the context nodes. And we have a method called set underscore models, which is used to set the data from context nodes to the view before the view is shown. So that's the way the data is transferred. So basically we have a corresponding attribute within the page attributes which will store the data same like the context nodes, and the data is transferred from context nodes to the view using the set underscore models method. So that's the way the view will be able to show the data which is present in the context nodes and again return back the data which is present in the view to context nodes. So any changes you do to the .html page has to be activated, or else it will be in inactive state and it will not be reflected in the view layout. And the advantage we have when we have the CHTMLB tags are the view will be configurable, and also the end user will get the personalization option, unlike when we do the hard coding in the .html. So basically it helps when we have a configurable view, because we need not modify the code every time to change the layout. Even the end users will get the personalization option. So to summarize, every view will have a .html page which might have a bit of coding either in CHTMLB tags or THTMLB tags. In general, with 7.0, most of the tags are CHTMLB so that the views are configurable. So if it is a CHTMLB tag, we will get an extra configuration tab and we will be able to configure the views layout. And every BSP page has page attributes which are equivalent to your context node names, and that's the way the data is transferred back and forth between the page and the context nodes. So moving forward, here we are seeing a diagram of view set wherein you can see that we have two views on the top and single view on the bottom. So here you see the actual image on how it is displayed. There is a view over here, there is a second view over here, and a third view which spans over the first and second column. So view set can be divided as you wish, as you have seen in the screen. So whenever you try to create a view set, it would ask us how many columns and how many rows we need, and based on our layout we will decide how many rows and how many columns we need, and then it would ask us to divide the rows and columns into view areas. So here the first row and first column is divided into one view area, the second column and the first row is divided into another view area, and the second row and the first and second columns combined is created as a one view area. So here you can decide how many columns, how many rows you need for a particular view area. So depending on how many rows and how many columns we need for a particular view area, we can give those details while creating the view set. And these details will be stored in the .htm of the view set, wherein we will be able to see the coding like the starting row and the starting column, and what is the column span and the row span. Here when we talk about column span and row span, here we are specifying how many rows this is going to occupy from the starting row. So for example, for defining the below view area here, we would say that the starting row is 2 and starting column is 1 and row span is 1 because it is occupying the second row, only one row, whereas the column span here will be 2 because though it is starting from the column 1, it is occupying the column 1 and column 2. So here if you say this is the column 1 and this is the column 2, so it is occupying two columns. So to specify that, you would say that the column span is 2. So this is how we define a view area, and based on the view area your views will be shown in that particular area which you defined. So here since we have defined the column span as 2, the table view which is shown in the third view area here is shown across the columns. So this is how it works, and while we create the view set itself, we generally decide on how many view areas we need and all that. So this is what we do when we need multiple views to be shown on the screen at same time. And after defining the view set, the assignment of view to a particular view area is done in the runtime repository again. So in runtime repository you will be having every view area mentioned under the view set, where you will be able to right click and add the view by clicking on add view. So moving forward, so as I had mentioned already, view sets also should be assigned to windows before they can be shown to the end user. View sets also cannot exist outside the UI component. The view set wizard will take the column size and row size and also the view areas which we are going to define within that view set, and every view area will have a unique name along with the starting column, starting row, and column span and the row span. So these are the parameters which we need to give for every view area. Once this view set has been created, for example, and you need to do any changes to the view areas, I mean the area which is occupied by a particular view area. For example, since we have seen in the previous slide, here you have defined that the third view area will occupy the whole space. So in case you have a requirement wherein you need to include the fourth view as well, then you need to go to the .htm page of the view set which is created and do the changes manually, because wizard will not support in modifying the layout again. So if you need to add any new view area or modify the existing view areas, you need to go to the .html page and do the modification within the view set, and then do the assignment within the runtime repository editor so that whatever has been intended will be shown to the user. So this is about the view set. Moving forward, so to talk about windows, each component must have at least one window. So while you are creating a component, you cannot create a component without at least creating one window. And in every component, window is mandatory, though views are not mandatory. So you can either have views and view sets or not, but window is a mandatory thing. So there are few components which are called as faceless components, where you will not have any views, but you will have a window. For example, the main components, like we discussed, there are three types of components. One is search component, second one is header component, and third one is main component. So search and header are the components which are embedded into the main component. So when this embedding is done in the main component, we do not create any views at all. So such components are known as faceless components, where we do not create any views. But in any case, views are not mandatory in a component, but window is mandatory. And it defines the root hierarchy of view sets and views in the runtime. So when you go to the runtime repository, this is the root node for any view or view set. So for example, you have a window and under it you have a view or view set. Then under the view set you will see the views. So this is a kind of root under which we assign either a view or view set, under which we see the other view or view sets. And the navigation is possible only within the views which are assigned within the same window. So if you have two views in the component which are assigned to two different windows, then the navigation between these two views is not possible. So for the navigation to happen between two views within the same component, they need to be available in the same window. And you cannot assign same view to multiple windows. So one view can be assigned to only one window at a time. So within the component, in case you have, for example, two windows, window 1 and window 2, and two views, view 1 and view 2, and you have assigned view 1 to window 1 in the runtime repository. Then when you try to assign view 1 to window 2, then the system would not allow you to assign it. So that's how it works. Each view can be assigned to only one window. It's the same case with view set as well. So for example, you have assigned a view to a view set and you assign the view set to window. Then you cannot assign the same view which you assign to view set again to window. So on a whole, in the visible views, this view should only appear once. So that's the principle. All the views visible on the screen at the same time is known as view assembly. So each view can be a part of view assembly only once. So that's the basic principle. Then talking about the navigation, window is not only responsible for the navigation between views within the component, it is also mediating when the component usage is used. So when the component usage is used and you are reusing other components, it will help us in managing the navigation between our component and the view which we embedded from the other component. Also, when we talk about reusing our component in other components, then the window will act as an interface view at that time. That's how it helps us in everything related to the reusing of this particular component. So when you go to the runtime repository and under the interface controller, if you check the interface views, you'll be able to find the windows names which we have created over there. So each window will correspond to one interface view, and that's how we will use when we reuse this component. So when we are reusing this component, we have to define which all interface views we are going to use in the using component. So that's how it works. We will see this in the system as well. And moreover, when you need to assign multiple views to a window, normally window can display only one view at a time. So in case you need to display more than one view, then you need to create a view set assign the views to a view set and then assign the view set to a window. So that is the procedure. You cannot show more than one view at a time. So view set is also technically a view, so you can show only one view set at a time. So to summarize, without a window, nothing will work in the component, because without window you cannot see anything on the screen. So window is a mandatory for every component, and system mandates that you create at least one window within a component. And any view which you want to see on the screen has to be assigned to the window, and you cannot assign a single view to multiple windows. Not only this, window will also act as an interface view when this component is being reused. So I think we have discussed enough about window. We will move forward. So to talk about view, view set and overview page. So we have already discussed about the view. So view set is a special type of view. So technically view set is also a view. The only difference is, in view set you will embed multiple views into it. So it will have all the view controller, context, event handlers, etc. But it will not have the context nodes, because you do not show any data within the view set. You show the data only within the views. Then speaking about overview pages are again a special type of view set. So overview page is a specific view set type. So in this type, the specialty is you can assign multiple views to the single view area, which is known as overview page. Normally, in the case of view set, for a single view area, you can assign multiple views, but at a time you can only show one view. It's a similar concept to the window. You can assign multiple views, but at a time you can show only one view. So likewise, in the normal view sets, for a single view area, you will be able to show only one view on the screen at a time. But in overview page case, though it is a single view area which is present, if you assign all the views to that single view area, it will display as different assignment blocks. So this is the normal case which happens with the header components. In the header components, when you want to display multiple details, then you will display them in assignment blocks. So for example, if you take the example of business partner, you will show the main details of business partner on the top, then the business partner relationships, then the business partner roles, likewise. So it keeps on going until the complete data is shown. So likewise, this arrangement of assignment blocks is basically the overview page, which is coming from assigning all the views to the single view area. This is again done in the runtime repository editor. So all the views which are assigned to this particular view area will come as assignment blocks on the screen. And we also have the options which you can select to load these assignment blocks. The three options are direct load, lazy load and hidden. So direct load will open up the view directly, whereas lazy load will open up the view only when you click on the link which will allow you to open. So it's a small triangular arrow which will be in the closed format. You need to open it up so that the complete view will come up. And hidden will remove it from the views which are visible to the end user. In case user feels that he needs it, he can go to personalize and activate it. So that's the three types of loading options. Generally we give the direct load for the details which are more general and which should be visible to the end user at any point of time. And lazy load is given to the details which are not much used in the day-to-day activities. And hidden is given to the views which are not at all required. That's how it works. Even this option of loading can be personalized by the user if the personalization is available for the end user. So he can select which assignment block to load lazy, which assignment block to load directly, and which assignment block to hide. So moving forward, so we have discussed about all the types of parts. So now to discuss about the controller types. Here are the major controller types which we are seeing. As we had already discussed, controller has the major role in WebAI to control the data flow from the presentation to API and vice versa. Because controller is a heart which controls everything. And when we talk about the view controller, this is the main controller which interacts with the end user. So it reacts to the events that occur in the corresponding view or view set, and it will manage the outbound plug, inbound plug, and the navigation details. So as we discussed already, a view is the part which is interacting with the end user, because that is the part which is visible to the end user. The other parts which we discussed, like window or component, all these are something which are not visible to the end user and which do not interact with the end user. But view is something which interacts with the end user, which has actions, input fields, everything. So when you click on a button or when you click on F for help, for example, that's a kind of event which is generated by the end user, and that has to be handled within the view controller. And that's what is done by the view controller. So it handles the events, it takes care of navigation and everything which is related to that particular view. Talking about window controller, as we had already discussed, it will not have event handling because it doesn't interact with the users, and it has navigation same like view controller. I mean, we have inbound flex and outbound flex. The one extra feature we have here is it can also handle the cross component navigation. It means it can handle the navigation from the view within this component to some other view which is in another component. That's a special feature of window. Then talking about the interface controller, here the interface controller is nothing but it's a kind of virtual controller which is created from the components within the from the parts within the component. So in the interface, so in interface controller, what we do is we will add all the parts which are exposed to the outside world. So for example, in our case, we will expose context nodes which are used for data exchange, then the interface views which are nothing but the windows which we created. So using the interface views and context, it will transfer the data. And also you need to expose the inbound and outbound flex which are visible to the outside world of this window. So only those flex which are exposed from here can be reused by the other comp. And also you cannot expose the context nodes from anywhere. The context nodes should belong to the component controller. So only the context nodes which belong to the component controller can be exposed through the interface controller. So that's the only restriction. So you basically expose the context nodes from the component controller, then you expose the windows by adding it as an interface view, then you expose the inbound flex and outbound flex of the window by adding the flex to the interface views. So these are the three things which you will expose so that this component can be reused by other components. So interface controller is a kind of virtual controller which consists of all these. Then the main thing, the component controller. So component controller are basically used to store and exchange data between multiple WebPI components. Not only that, component controller is the initial controller which is loaded when the component is loaded to the runtime. So it is the main controller which is getting loaded first, and that is the controller which dies at the last. So it manages kind of life cycle for that particular component. And apart from that, it is also used to store the data which can be exchanged between multiple components, because as I had mentioned already, in the interface controller, the context node which you expose should always belong to the component controller, which means only the context nodes of component controller can be reused in the outside component. So that way we can send data from one component to the other component by exposing the context node of the component controller of that particular component. And to talk about reusing other components, we do this in WD underscore usage underscore initialize method within the component controller. So there we have to define the mapping of context nodes between the usage which we used and the current component. So in this method you will decide which particular context node of this component will be linked to which particular context node of the other component. So that way you are basically mapping the context node of this component to the other component so that the data flows from this context node to the other context node. So moving forward. So this is the kind of coding which is done there. So you see that there is a method bind context node which is used, and here you will be passing the target node name and the node to bind. So these are the context nodes which are used to bind the data. So one of the context node will be bind to the other context node which is given over here. Here IV underscore name is the controller which is the present component controller. Then IV underscore target underscore node name is the name of the context node in this current controller, and IV underscore node underscore to bind is the name of the context node of the component which we are using. So target is actually the current component's context node, and node to bind is the context node of the component which we are reusing. So moving forward, so this is the slide talking about the custom controller. So custom controller is basically used for data transfer across the views within the same component. So unlike component controller, you can create any number of custom controllers. So in a component, we can only have one component controller, whereas we can have n number of custom controllers. And as I had already mentioned, component controller is automatically loaded when the component is loaded. That is the first controller which is loaded. But here the custom controllers are loaded on the request basis. So the custom controller will only be loaded when it is required. So the instantiation of custom controller happens when you use the context for the first time, or it can also be instantiated manually by calling the method getCustomController by giving the custom controller name. So in these two ways you can instantiate the custom controller. So when we say that using the context node, we generally use custom controller's context node to transfer the data from view 1 to view 2. So for example, I have a context node called cn1 in view 1, and I have a context node called cn2 in view 2, and I want to pass the data from cn1 to cn2. So I will create a context node within the custom controller with the name cn, and then bind the context node cn1 to cn, and same way bind the context node cn2 to cn. So when we mean binding here, when it is bound, or when two context nodes are bound to each other, the data transfer happens automatically. The framework will take care of handling the data transfer between these two nodes. So that way, when we have two nodes bound to the same node within the custom controller, then automatically the data flows between these two context nodes. So whatever you enter in the input field on the screen will automatically flow to the other screen, because there is a relation between the input field and your context node. So whatever you enter in the input field will go to the context node. Then from the context node of this view to other view, it will automatically traverse. And again the other view will show whatever data is present in the context node of other view. So that way we will be able to see the data which is entered here in the other view. And here we use the same method, do context node binding, to bind the context node. And we have a wizard which writes this coding for us. So we don't even need to write this coding. When you right click on a particular context node, you will get an option to bind. So when you select the context node to which you want to bind, automatically the wizard will write this code for us. So to summarize, custom controllers are basically used to transfer the data between two views within the same component. It cannot be used to transfer the data out of the component. And we can create any number of custom controllers, and this instantiation of the custom controller happens on the request basis. So on a whole, to summarize, we have discussed about 5 types of controllers till now. One is the view controller, second one is the window controller, third is the interface controller, fourth is the component controller, and fifth is the custom controller. So these are the major controllers which are present within the WebAI framework. So moving forward, now we will discuss about the context. So context is a part of every controller, and what context essentially does is it wraps the class which will connect your controller to the context nodes. So context nodes are actually storing the data, and context acts as a bridge between your context nodes and your controller class. And we can create context node using a wizard. When you right click on the node context nodes, you will be able to see an option to create the context nodes. So it will open up a wizard which will guide you through the whole creation process. So when we talk about how this linking happens, basically in every controller we have a variable called typed_context, which is an attribute within the controller which will always refer to your context. So what we mean here is every IMPL class, which is the implementation class or the controller class, will have a reference to its context class or CTXT class using a reference variable typed_context. Then within the context class, it will have reference variables for every context node which is created under this context. So for every context node which is created under a particular context, it will have a reference variable pointing to each context node. So that's how the linking happens from the controller to the context. And also every context will have an attribute called owner, which will specify which controller or which IMPL class is owning this context. So that way it's a two-way relationship. Then when you define a context node using a wizard, you get three options. One is model node, second one is value node, and third is context node for the drop-down box. And context node for the drop-down box is now obsolete because we have getP method, so we are not using this anymore. Model and value node are the two things which we are still using. So model node is used when you have a relationship for this particular node with the bool. In the same way, it has a relationship with the database as well, because bool will transfer the data from bool to Genil, then Genil will transfer to API, and API will transfer to database. So that way, whenever you want to store some data or retrieve some data from the database, we go for a model node using the Genil model. Whereas value node is generally used in the scenarios where we do not store the data back to database, and it's only for calculation purpose. So for example, you might have a field where you are displaying a difference of two numbers, or probably you are displaying the status of a particular delivery, for example. So you are displaying different symbols like green, red or amber depending on what is the delivery date and what is the current date. So for example, the delivery date has already passed and you still did not deliver, then it will show as a red. Whereas the delivery date is either tomorrow or day after tomorrow and you are still yet to deliver, then it will show amber. And the delivery date is in future and the delivery is already done, then it will show as green. So in such scenarios, you do not need to store whether it is red, amber or green. It is calculated dynamically based on your delivery date. So delivery date will anyway be there in the order, and you would detect the current date from it and decide upon whether you need to show red, green or amber. So that is something which is a kind of calculated field which is only for display purpose. You would not store it back to the DB. So for such situations, you will go for a value node. So moving forward, so this slide talks about the details. So as I had mentioned, model node is representing the structured data which is connected to the DB via the bool, and model node is always having a underlying general reference, and it always stores the data to DB, and without a bool entity you will not be able to create a model. So as we had already seen in Genil model browser, we will be able to see the hierarchy of these bool entities or Genil objects. So such hierarchical view is possible even in the context nodes if you arrange them. We will see that in the system. And value node, it represents the data which is not connected to any DB layer. So that's what we had discussed. And we had also discussed that the third option is no more used because it is up. So to summarize, every controller class is connected to its context class using a variable called typed underscore context. And every context class is connected to its context nodes class using a variable which will be named with the context node name. And every context will also have a reference to its owner or the implementation class using the variable owner. So these are the three things which you need to remember. And then in context node, you have two types of context nodes. One is value node and another is a model node. So model node is something which is used when you get the data from the DB and set the data to the DB. So that's a kind of general thing which you do. And value node is used when you don't have any relationship with the DB and you are just using it for a temporary node. So this is about the context and context nodes. And this forms the model part of your MVC design within a particular view. So if you see the different nodes which are present, so every model node or value node should have CLBSP WD context node as the superclass. So it's same for model node and value node. And in case it is showing the data in a tabular format. Then CLBSPWD context underscore node underscore TV is the class which it has to have as a superclass. And for deep table it is DTV. And for drop down list box it is DDLV. And for tree structure it is tree. And for advanced search page it is ASP. So these are the specialized classes which are given by SAP for all these scenarios. So for every scenario we generally have this class as the superclass. In some cases when the wizard doesn't have the capability to set this class as the superclass, we generally go and manually change the class in the superclass field. So moving forward, so context node binding is basically carried out between either your view controller and your custom controller, or your view controller and the component controller. So this is basically used to transfer the data from one view to other. So when you need to transfer the data from view 1 to view 2, basically you need to bind the context node of view 1 to the custom controller or component controller, and same way the context node of view 2. So that way the data transfer happens. And any data which you show on the screen has to come from context. So the business objects which we have seen in the model store the data in the attribute structure which is present with the business object, and they are called as bool entities in the bool. So each context node needs to store the bool entity which is responsible for having data in it. So to store that, every context node will have a variable called collection underscore wrapper. The context node is not capable of storing it, but it has a collection wrapper which will store this bool entity. So these bool entities are stored into the collection wrapper, and collection wrapper is assigned to the context node. And this context node has methods like set collection, get collection, which will set and get the collection from the collection wrapper. And the type of parameter which it expects is IFBOL BO COL, which means it's a collection. So this is how the storing of data happens. So basically every context node will have collection underscore wrapper variable which will store the bool entities. So whenever you need to get or set the entities, you need to get from the collection wrapper. And we had already discussed that type underscore context is the variable which will refer to the context object. So when we say context node binding, we are actually binding the collection wrappers of two context nodes. So with this, we will end this session, and we will continue with the remaining concepts of componentization in the next session. Thank you.